Hello everyone, this is John Jenkins, and I would like to bring you the knapsack problem. I have just completed the knapsack problem. I had a pretty big error in the program. So basically, the knapsack problem is a seminal problem in programming, in which you're going on a trip, right? And you have a knapsack, and you're collecting your supplies for the trip, and based on the number and value of the items you there's a number there's a size limit, there's a total size limit for the knapsack, and there's a total value limit for the knapsack, and you want to be below the size limit and above the value limit. So this is my program for the knapsack problem. So a lot of people, when they program the knapsack problem, they already know the number and type and value and size of each item, and they just code that into the program. But I decided to go the dynamic route, and I let the user put the values in themselves. So I'm going to go ahead and demonstrate the knapsack problem. So first question, what is the name of the item in question? I'm going to put book. And what is the size of the item? Books are, the types of books I read are pretty large. So I'm going to put 3. And what is the value of the item from 1 to 5? It's about a 3. Would you like to add another item, yes or no? What is the name of the item in question? Toothbrush. And what is the size of the item? I'll say about a 1. It's about a 1. What is the value? It's not a crazy high value for a toothbrush. It's around 2. It's not going to be 5 out of 5. So what was the last thing? Money. And hopefully the size of my money is a 4 out of 5. Hopefully the size of my money is a 4 out of 5. And what is the number of random I made a mistake. I'm sorry. I gotta start all over again. So I made a mistake. So okay, what is the book 3 3? Would you like to add another item? Yes. Brush 1 2. And would you like to add another item? And what is the name of the item in question? Money. So like I said, I hope my money is the size of 4 out of 5. And the value of the money is about a 5, depending on what currency you're talking about. So negative. All right, so I said no for the last question of do I want to add another item. So now it's going to ask me, what is the maximum size of the packs you want to create? So that the maximum size of the pack, so it takes, for each pack you have a certain number of items, and it adds up the size of each item, and you get a maximum size for the pack. All the items added together, the maximum size. So I'm going to put 16. That's a good number. What is the number of random? So it's going to go through a number of random packs. It's going to create a number of random packs, and out of that random number, it's going to create a group of solutions based on that random number. And so I want to add 300 random packs. And what is the average item value threshold number for each pack? So the way that works is that when you have a pack, based on the total number of items in that pack, the average value should be a number between 1 to 5, because the maximum value is 5 and the minimum value is 1. So if you take that maximum and you divide it by the number of items in the pack, it should average 1 to 5 for each item. So I'm going to put an average of 4, and here are my solutions. So let's see. Okay. Okay. All right. So this is a little bit different. So basically with this pack, it has an item of one. Uh, it has one item, right? So the pack size is below 16 because the value of money is 5. I'm sorry, the size of money is 4. The size of money is 4, so the size is 4, which is less than 16. And the average of the value of the money is 5, and there's one item in the pack, so the average item value is 5, which is higher than 4, which is our threshold. So with the second book, with the second pack right here, we have, and none of these packs are repeats. None of these packs are repeated. They're all original. So with this one right here, with the second pack, we have one book, which is the size of 3, one toothbrush, which is the size of 1, which is 4. It's a total 4, plus 3 monies, which is 12. So 4 plus 12 equals 16, which is right at our limit right here. And the value of the book is 3. The value of the toothbrush is 2. That's 5. The value of the 3 monies is 15. So the total value is 20. And divide that by 3, you get about 6.66, which is higher than 4, which is our threshold for the average value the average value compared to the number of items in the pack. So it would be different if I was comparing it to the number of items available. Then it would be a much different story. But so I thought that this would be a much better way of going about it. I guess I could have had a minimum size as well. Um, that would be helpful as well. But this works out well. I have a very good. I have a selection of answers. I was going to create this advanced sorting system that allows you to sort through all of the different options and find the absolute best answer based on the sorting system. But I really didn't know how I was going to add the sorting system, so I decided to let the user decide how it's going to be sorted. So the user adds in the average item value himself or herself, and based on that, the solution, a group of solutions, is created. So that is my solution for the knapsack problem. It's a lot harder than the Fibonacci sequence or the FizzBuzz program. So I finished the Fibonacci and the FizzBuzz a couple of weeks ago. But this is a lot harder than that because you have a lot of different moving factors, and you have to figure out how to make things work together. And I made a lot of errors with this program, but I'm glad I was able to fix it and get it to work. And like I said, none of these packs are repeated. They're all original, and this is correct because there's 0 items, so you know you're dividing 0 by 0, which is not going to give you a wrong answer in the context of this programming language. So that was my solution for the knapsack problem. This one has a size of eight, a size of 8 because there's two monies, and an average value is 5, which is above the 4 threshold. Yeah, so that is my solution for the knapsack problem. So let me know what you think, and I will be doing a lot more programming in the future. So I hope to see you around. Thank you very much, and goodbye.